Bismillahirrahmanirrahim. Assalamu alaikum, dear student. Today we will discuss classification of elements. A periodic table is the study of various properties of the elements. Following scientists have done major contribution towards the modern periodic table. Lewis, he listed 33 substances, including life and the substances belonging to all the kingdoms of nature. For example, gases, metals, non-metals, and the substances which form the salts. This is table presented by Leviser. Leviser is a table of simple substances including gases, nonmetals, metals, and the substances which form the salts. John Dalton, according to him, all bodies are made up of small particles or atoms of matter bound together, and the bodies are perfectly alike in weight and figure. He listed elements. Dalton's elements including oxygen, gold, nickel, arsenic, cerium, strontium, zirconium, etc. Al-Razi. He classified the elements on the basis of origin, physical and chemical properties of the substances. Berzelius. He solved the problem of the chemical sign of the elements. He distinguished them in the following manner. For metallides, only initial letter was used. In the class of metal, he distinguished those that have the same initials with other metals or a metallide by writing the first two letters of the word. If the first two letters be common, then he used first consonant which they have not in common. For example, carbon, cobalt, copper. Elements known to Berzelius. DR.Rehan, he proposed the concept of triads. According to him, the atomic mass of the middle element is the mean of other two. For example, here, atomic mass of the bromine is the mean of the atomic masses of chlorine and iodine. A French scientist, Alexander de Champ-Cortes, devised a spiral graph that was arranged on a cylinder which was known as telluric helix because tellurium was the element in the middle of the graph. This was presented by Alexander de Champ-Cortes. He arranged similar elements onto corresponding points above or below. For example, lithium, sodium, potassium. He suggested that the properties of the elements are the properties of numbers. Newlands proposed the law of octaves. According to him, that every eighth element had same property with the first one. He classified 62 elements. Mendeleev, his first table was published in German chemistry periodical. According to him, the properties of the elements are the periodic function of their atomic masses. This is the first sketch of his periodic table. Salient features of Mendeleev's periodic law. Vertical columns are known as groups, horizontal rows are known as periods. Arrangements was done according to increasing order of atomic masses. Elements showing similar properties appeared at regular intervals. Some gaps were left, also predicted the properties of those elements which were yet to be discovered. Defects of Mendeleev's periodic table. Number 1 is the position of hydrogen. Hydrogen resembles with halogens and alkali metals, therefore position couldn't be decided. His table didn't give any idea about the structure of atoms. He also didn't explain the position of lanthanides, actinides, and position of isotopes. He also placed dissimilar elements together. Reason for the periodicity was not clear from his periodic table. Mayer produced a table of 28 elements which he listed by their valency or combining power. Later on, he incorporated transition metals in another table in 1868. Moseley, using X-ray diffraction spectra, showed a systematic relationship between wavelength and atomic number. According to him, the physical and chemical properties of elements are the periodic function of their atomic number. Benefits of Moseley's law: number one, correct arrangement of some elements. For example, argon before potassium, cobalt before nickel. Position of rare earths, position of isotopes, placement of noble gases, and position of coinage metals. Seaborg, he was the discoverer of 10 elements, including americium, californium, and seaborgium. He also reconfigured the periodic table by placing the lanthanide and actinide series at the bottom of the table. He also proposed that to extend the periodic table up to atomic number 168. Periodic table: these alkali metals, alkaline earth metals, transition metals, metalloids, chalcogens, halogens, noble gases, lanthanides, and actinides. Difference between metals and non-metals. Metals have shiny luster. They are ductile, good conductors of heat and electricity, while non-metals don't have a luster and poor conductor of heat and electricity. Metalloids have characteristics of both metals and non-metals. Hydrogen. Some commercial uses of hydrogen. It is used in hydrogenation of fats and oils, rocket fuels, welding, and used in the study of superconductivity. Group 1, alkali metals. These are soft metallic solids. Colored flames: lithium gives crimson red color, sodium gives orange color, potassium gives lilac color, and the reaction with the water produce hydrogen. Group 2, alkaline earth metals. Burning magnesium gives intense white color. They react very slowly with water. Barium gives apple green color, and strontium gives crimson red to scarlet color. Group 3A. These are Group 3A: gallium, used in electronic circuits, semiconductors, LEDs, and even in nuclear medicine tests. For example, gallium 67, used for diagnosis of cancer, thallium used as an insecticide and also used in photoelectric cells, indium used in rectifiers and photodetectors, and some are precious stones, for example sapphire and ruby. Aluminum used in packing materials. Gallium melts at 29 degrees. Group 4, lead batteries, silicon chips, quartz, germanium used in IR detectors, tin metals, and applications of carbon, including carbon nanotubes, carbon sphere, polymer spheres, and finally diamond. Group 5, nitrogen is used in the production of ammonia, phosphorus for matchbox, arsenic used in semiconductors, wood preservatives, and bullets. Bismuth used in fire detectors, fire extinguishers, and lipstick. Antimony used for IR detectors, batteries, and bullets. Group 6, sulfur used in matchboxes, insecticides, fungicides, and antibacterial. Selenium used in solar cells, photocells, photographic toners, tellurium used in semiconductors. Group 8 noble gases used in photographic flashes, lamps used for detection of radiations, for example, neutron, X rays, welding, TV tubes, vacuum tubes, lasers, and used in treatment of tumors. Transition elements, these have range of applications from our household to industry and in lot of application in medical sciences. Thanks for watching. Please like and subscribe our channel for more videos. Take care. Allah Hafiz.